I wanted to go through a quick example for the method of sections. This is an easier way to solve for the internal forces in truss structures if you don't want to know the entire thing. I thought we'd go through the Pratt Truss. So let's say you have your quadcopter and it's doing a little survey and it finds, oh no, a rusty chunk in your bridge. Now, most of the bridge is just fine. It's just this one little spot that you are worried about. So you don't need to solve for the entire bridge. You just want to solve for this one little spot. What is the easiest way to do this? Number one, we're going to start just like we started before. You're going to solve for the reaction at the supports. Next, you're going to carve the truss into sections. I guess that's why they call it method of sections. This is actually a technique that works for more than statics. Any engineering problem that's out there, no matter how complex or hard it is, you can always carve it up into little bite-sized pieces. And the trick for carving something up into sections, into little pieces, all you have to do is keep track of what's going to cross your system boundary. And you can define your system as anything you want it to be. And if you can just keep track of what crosses that boundary, you can start piecing together more and more complex systems. Okay, so we're going to slice it through the piece that we are interested in finding out about and divide it into sections. Now, looking at this, you have a choice. We can either analyze the right hand of this bridge or you can analyze the left hand of this bridge. Of course, the left hand looks easier, and that's part of the art form of method of sections, is learning how to carve this up in the most efficient way possible. Okay, so let's look over here at this left hand section. So what we're going to do is draw a free body diagram of just this piece. And anything, anywhere that our boundary cuts through our system, we're going to need to replace all of these with a force. So notice how we've cut this apart. So we've only cut through 3 beams. We have Fx, Fy moment, we have 3 equations, and so we can solve for 3 forces. Okay, what's the easiest way to go about solving for forces? And it usually starts with a moment calculation. Remember, you don't have to take the moment around a point that's actually on the structure itself. Find a point that bisects some of your unknowns. So right here, this would be a great point to take your moment around. And doing that, we can find one of our unknown forces. So using the dimensions of the bridge, we can come up for F. Remember, counterclockwise is positive. And then if we come to the left to our 1500, this would give us a negative or clockwise rotation. And so you can easily see that here's one of our first forces, 3375. Okay, next up, where would be another good spot to take the moment around? Okay, so how about right here for our moment? This ends up giving us just one little force down here at the base that we can calculate. Plugging in our dimensions, we have 4 meters times our force down here is equal to 6 meters times our 1500. So there's another force we have, and all that's left is now our diagonal. And for our diagonal, we can look at adding everything in the x direction to 0. So 2250 plus 1125 is equal to 3375. In the y direction, the only thing in our y direction is the 1500. So 1500 up has to be 1500 down. A squared plus b squared equals c squared. And at the end, you can check that we have a 3-4-5 ratio for our forces. So, not too bad. You can slice into any little piece of your truss structure. You can solve for just one little piece of it, and you don't have to look at the entire thing. And know that this is true for any engineering problem, that you can carve it into pieces And the trick is you just have to keep track of anything that crosses your system boundary, and you can find out anything you need to know about whatever is inside of your little piece of the puzzle.